Right now, somewhere on GitHub, a developer is reinventing the singleton pattern for the third time today. Studies show that roughly 40% of architectural bugs in object-oriented code trace back to one root cause: engineers solving structural problems that were already solved badly in 1994. Design patterns are not academic theory. They are the difference between code that ships and code that becomes a graveyard. There are 23 classical Gang of Four patterns. You don't need all of them, you need 10, the 10 that show up in every framework, every backend, every code base you'll ever touch. Singleton, factory, builder, prototype, adapter, decorator, facade, strategy, observer, and iterator. Master these, and 90% of architectural problems become solved problems. Let's open the toolbox. First, what actually is a design pattern? It is not code. It is not a library. It is not something you import. A design pattern is a named solution to a problem that keeps showing up in software design. Like recipes, you don't reinvent how to make pasta every time you cook. You follow a pattern. Patterns give engineers a shared vocabulary. When someone says, just use a strategy here, the entire team knows what that means in 3 seconds flat. All 23 classical patterns split into 3 families: creational, see how objects get made; structural, how objects fit together; behavioral, how objects talk to each other. Every pattern in this video lives in exactly one of those 3 buckets. Learn the buckets and the patterns stop feeling random. The singleton, the most famous pattern in software, also the most abused. The rule is simple: ensure a class has exactly one instance and provide a global point of access to it. Database connections, configuration objects, logger instances, anywhere you need exactly one of something, singleton. But here's the catch. Singletons are the energy drinks of design patterns. Useful, occasionally necessary, and dangerous if you reach for them every time you have a problem. Overuse a singleton, and you have just invented a global variable wearing a costume. Use them for genuinely shared resources, not because they are convenient. The factory pattern. You don't construct objects directly, you ask a factory to do it for you. Why? Because direct construction couples your code to specific classes. Factories give you a single choke point where object creation lives, and the rest of your code only knows about interfaces. Add a new database driver, a new payment provider, a new file format, change one factory, nothing else moves. Think of it like ordering coffee. You don't walk into the kitchen and operate the espresso machine yourself. You tell the barista latte, and a latte appears. The barista is the factory. The espresso machine is the implementation. You don't care how, you care that you got the right object. The builder pattern, for when constructors get out of hand. If you have ever seen a function called with 12 arguments, half of them Booleans, half of them undefined, you have seen the problem builder solves. Instead of one giant constructor, you chain method calls, set this, set that, build. The final object pops out, fully configured, perfectly readable. Builder turns this: new user, true, false, null, null, 30, false, true, undefined, into this: user dot with name dot with age 30 dot with admin true dot build. Same object. One is a war crime, the other is code your team will not curse you for writing. The prototype pattern. Don't construct new objects. Clone existing ones. Useful when object creation is expensive, heavy database queries, complex initialization, deep configuration trees. Instead of paying that cost every time, you build one canonical instance and clone it whenever you need another. JavaScript developers, this is literally how the language's inheritance system works under the hood. You have been using prototypes since day one, whether you realized it or not. The adapter pattern, the pattern that saves your career when the API team ships a breaking change at 4 p.m. on a Friday. Adapter wraps an incompatible interface in one your code already understands. Your code stays the same. The adapter translates. It is the power plug converter of software. Every legacy system migration in history is essentially one giant adapter pattern. The old system speaks SOAP. The new system speaks REST. Nobody has time to rewrite 10 years of business logic, so you write an adapter, ship it on a Tuesday, and never think about it again. until it becomes load-bearing infrastructure that nobody is allowed to touch. The decorator pattern. Add behavior to an object without modifying its class, without breaking inheritance, without rewriting a single existing line. You wrap the original object in another object that adds capability, wrap that in another, stack them like layers, logging, caching, authentication, compression, all classic decorator use cases. Every middleware system you have ever used in Express, Django, or Rails is decorator wearing a different name. Imagine a coffee, plain coffee, wrap it in a milk decorator. Now it's a latte, wrap that in a caramel decorator, caramel latte. Each wrapper adds one thing. The original coffee object never knew any of this happened. That is decorator, composable behavior, zero inheritance hierarchy. The facade pattern. Hide a complicated subsystem behind one simple interface. Your media library has 50 classes for codecs, buffers, file headers, and stream parsers. Your application doesn't want to know any of that. It wants to call play this video. The facade is that one method underneath chaos. From the outside, one clean call. Every SDK you have ever used is a facade. Stripe doesn't make you understand PCI compliance, card networks, fraud detection, and bank settlement protocols. You write stripe.charge. The complexity didn't disappear. It just stopped being your problem. That is the entire value proposition of a good facade. It makes someone else's complexity invisible. The strategy pattern. Define a family of algorithms, encapsulate each one, and make them interchangeable at runtime. Sorting algorithms, payment processors, compression methods, pricing rules. Anywhere your code says, do this thing, but the thing might change. Strategy. You inject the algorithm as an object. Swap it out without touching anything else. Strategy is the cure for the most common code smell in the industry. The giant if-else chain that grows by one branch every sprint. If your function looks like if type is A, do this, else if type is B, do that, else if type is C, you don't have a function. You have a strategy pattern that hasn't been refactored yet. The observer pattern, the backbone of every reactive system on the internet. One object, the subject, maintains a list of dependents called observers. When the subject changes state, every observer is notified automatically. Push notifications, real-time dashboards, stock tickers, the DOM event system in your browser, React's entire rendering model, all observer. Observer is just a fancy name for I'll text you when something happens. Twitter is observer at planetary scale. You follow an account. You have registered as an observer. They post. You get notified. Multiply that by 500 million users and you have built a distributed system. Patterns scale terrifyingly well when you don't realize you're using them. The iterator pattern provides a uniform way to traverse a collection without exposing its internal structure, whether the collection is an array, a linked list, a tree, a database cursor, or a stream of network packets. The iterator gives you a single consistent interface. Get next. Are we done? Repeat. Every for-of loop, every Python iterator, every database result set, iterator pattern baked into the language. Now the warning. Patterns are tools, not goals. The most dangerous engineer on any team is the one who just read the Gang of Four book and is looking for somewhere to apply what they learned. If your code base has 15 patterns and 300 lines of business logic, you have not built software, you have built a museum of design patterns. There is a name for this. Pattern fever. The cure is asking one question before every refactor. Does this pattern make the code simpler? Or does it make me look smart in code review? If the honest answer is the second one, delete the abstraction, ship the simpler version, and go home. The best code is boring code. Patterns serve the code, not the other way around. Let's lock it in. Creational patterns control how objects get made. Singleton for shared instances, factory for centralized creation, builder for complex configuration, prototype for cheap cloning. Structural patterns control how objects compose, adapter for incompatible interfaces, decorator for composable behavior, facade for hiding complexity. Behavioral patterns control how objects communicate, strategy for swappable algorithms, observer for reactive notification, iterator for uniform traversal, 10 patterns, 3 families, 90% of architectural problems. Patterns are not the answer to every question. They are a vocabulary that lets you ask better ones. Learn the vocabulary, then forget the names and just write good code